Finding zeros of a function. Let's start off by reviewing the general form for a quadratic equation. Remember when we factored, we learned about the quadratic equation, and we learned that there were three coefficients, a, b, and c. A in front of the x squared represents the quadratic term. B in front of the x represents the linear term, and c represents the constant term. So what we're going to learn is that the general graph of a quadratic looks something like this, where it looks kind of like a big smiley face. And what we call this type of graph is a parabola. And if we look at the parabola, I'm drawing your attention to 3 points on the parabola. One of them is down here, and this is going to be what we call our minimum. These points here that lie right on the x-axis, these have various different names, but they all mean the same. Sometimes we call these the zeros of the function or zeros of the graph. We can also call this place where they intersect the x-axis the solution. And then we can also just call this the x-intercept. So when we talk about zeros of a function, we're really talking about where the graph intersects the x-axis. And remember that the zero of a function is basically the value of x when y equals 0. So in this example, we would have an ordered pair of 4 and 0 and negative 4 and 0 as the zeros of this particular quadratic. Let's start our notes on finding zeros of a function. First of all, we can see that this is a parabola. It's the graph of a quadratic equation. It has a minimum, and this quadratic is opening up to the top, or the top part of the graph. It's opening up to the top. It looks like this quadratic has two x-intercepts. One is here at x equals -3, and one is there at x equals +2. So remember from the previous video that solution, zeros, and x-intercepts all are referring to the same thing. So solution, zeros, and x-intercepts are all referring to the same thing. So what I'm going to do is just say that these are all going to be equal to x equals -3 and do a comma, x equals +2. All right, let's look at the next graph that's in the lower left column. Now this parabola is a little bit different. This quadratic is a little bit different because this graph is opening up to the bottom. So really, if we were going to make this look a little bit clearer, we would see that we would have a parabola that looks like this, that would have a maximum point somewhere up around in here, and then it's going ahead and growing downward as opposed to upward like our other one was. Then we can see that this has two x-intercepts just like the other one. It looks like this one's at x equals -5 and this one's at x equals +7. So again, we know that solution, zeros, and x-intercepts are all referring to the same thing. They're referring to the value of x when y equals 0. So in this graph on the bottom, we would have the solution, 0, and x-intercepts. All of them mean the same thing. X equals -5 and comma x equals +7. Let's learn how to solve equations by factoring. Let's start off with some review. Let's look at this example here. We have a times b equals 0. And the question below says, what do we know about a and b? Well, what we know is that either a or b has to be 0. So we know that either a or b must be 0. Okay, and again, we get back to the multiplicative property of 0. If you multiply any term by 0, your product or your product is also going to be 0. All right, let's get back to the notes. So the first thing we're going to do is we're going to make sure the equation is in the correct format before we try to solve it. We're going to make sure that our equation is equal to 0, and we're going to do that in our examples below. We're going to make sure that our quadratic equation is in descending order, so that means it's going from x squared to x to a constant. And then finally, we're going to make sure that our first term in the quadratic equation is positive. The next step is we're going to factor. So we're going to use the same methods as we learned earlier, either GCF, difference of squares, grouping, or Xbox. So our goal of solving equations is to find where does the graph intersect the x-axis. And remember, solutions were also referred to as zeros of a graph, solutions, and sometimes we also call these or refer to these as roots. So all three of those terms all refer to the x-intercept. So how do we find the zeros, solutions, or roots of a quadratic equation? Well, we have to set each factor or each GCF or each parenthesis group equal to 0. Okay, and then we would solve for x. And again, we can always check our answers by using our graphing calculator, or we can check our answers just by substitution. So let's look at our first example, number 1, x plus 5 times x minus 4. So on this example, we see a quadratic that has been already factored into two prime factors, x plus 5 and x minus 4. So remember, our first step is to set the product of these two factors equal to 0. So we want to find the values of x that would make the product 0. So how do we do that? We just set each individual factor equal to 0. So we would say x plus 5 is equal to 0, and x minus 4 is equal to 0. Now we would just solve each equation using inverse operations. Subtract 5 on both sides. So now we can see that one of our solutions is x equals negative 5, and another one of our solutions is going to be x equals positive 4. So the solution would be x equals negative 5 and x equals 4. So this quadratic equation has two solutions, or crosses over the x-intercept 2 times. Let's look at the next example. X minus 9 times 2x plus 9. Again, we already have our factors set up, and we have the product of these two factors equal to 0. So let's go ahead and set each individual factor equal to 0. X minus 9 is equal to 0, and 2x plus 9 is equal to 0. So all we're going to use is inverse operations to get x by itself. So we're left with x equals 9 as being one solution. On the right, we have a two-step equation, so we get 2x is equal to positive 9, or x is equal to, this should be negative 9. X is equal to negative 9 over 2. All right, let's solve number 3. We're going to start by setting each factor equal to 0. So we get 3x minus 4 equals 0, and 2x plus 1 equals 0. Let's add 4 to both sides so we can get x by itself. So we get 3x equals 4. We divide each side by 3. We get x equals 4/3. Okay, on the right side, we're going to subtract 1 from both sides. We're going to get 2x equals negative 1. Divide each side by 2. We get x equals negative 1/2. So we see we have two values of x. So the function is equal to 0 when x equals 4/3, and when x equals negative 1/2. So if we were to graph that, and you could graph this on your calculator, what we would see is we would see the value of negative 1/2 over here, and then the value of 4/3 over here. This is supposed to be a 4. And then we know that our parabola is going to be opening up to the top. So what I want to do is show you what that parabola is going to look like, a pretty rough version of what it's going to look like. So I know I'm going to have a parabola that opens up to the top. So I'm going to have something that looks like that. Let's look at example 4. We have negative 72 equals negative 2g to the second power. So on this one, I can see right off the bat that this is not set up in the right format. Because first of all, we have to have our terms in descending exponential order, which they are not. And then we also need to set our expression equal to 0. So let's go ahead and take care of that first. We're going to move the negative 2g squared over to this side. So that's going to give us positive 2g squared minus 72. And now we can set that equal to 0. Now, if we look at 2g squared minus 72, we need to factor it. So what would be the best way to factor that equation or that binomial? Well, we know we always want to start off by looking for the greatest common factor. And I can see that the greatest common factor of 2 and negative 72 is just going to be positive 2. So let's factor out the 2, and we're going to get 2 times g squared minus 36. And all of that is still going to be equal to 0. Now, what you should see right now is you should see that we're left with one factor that is a difference of 2 squares. So let's keep factoring it until we get down to only prime factors. That's going to leave us with 2 times g plus 6 times g minus 6 is equal to 0. Now we already have this factored. We have it factored down into primes. There's nothing else that we can do with this one. So let's go ahead and set each one of our factors equal to 0. So the 2, there's nothing we can do with the 2, but we set the g plus 6 equal to 0 and the g minus 6 equal to 0. Those are easy one-step equations to solve. We subtract 6 from both sides. We get g equals negative 6, and on this side we would get g equals positive 6. So if we were to graph that, what we would have would be an x-axis that has 2 values here that are marked, negative 6 and positive 6. We have an upward opening parabola, so we would see something that looks like this. Okay. Example 5, we have x plus 3 plus 4x squared equals 5x. Now I can see that I need to move this 5x over to the left side so that I can set this whole polynomial equal to 0. And at that point, then I can factor and solve. So what does that look like? Well, let's move the 5x over. So we would get x to the third plus 4x squared minus 5x equals 0. And this should be x to the third. Now we can go ahead and start off factoring by looking for a GCF. Do you see a GCF? Well, you should see that each one of these terms in the polynomial has an x, and that the lowest exponent is x to the first power, so that we can go ahead and factor out an x to the first power since it's common to all. So we're going to have x times x squared plus 4x minus 5, and all of that is still going to be equal to 0. Now I have a trinomial that I can factor. So I can factor this using Xbox. Okay, so let's do that. So we're going to take x, and then we're going to set up a spot for two binomial factors. And these are all going to equal 0. So let's go over here on the side and figure out what our magic pair would look like. So I'm going to draw an x. I'm going to put the product of a and c over here on the right, which is -5. And then I'm going to put my linear term, or 4, here. So I want two numbers that when multiplied equal -5, and when added together are going to equal +4. Well, we should know that those two numbers are going to be 5 and -1. 5 times -1 is -5. 5 plus -1 is +4. So let's go ahead and factor. So we're going to have x times, and then we can put our x's here. One of our magic pair is +5, and the other one is subtracting 1. So now we're factored into prime, so now we can just set each factor equal to 0. So here we have three values of x. We have x, x plus 5, and x minus 1. So we need to solve for all three. So let's do that. So we're going to have x equal to 0. Then we're going to have x plus 5 equal to 0. And then finally x minus 1 equal to 0. So x equals 0, that's already done. So we know that one of the solutions to this polynomial is going to be x equals 0. One of the solutions is going to be x is equal to -5. And one of the solutions is going to be x is equal to +1. So what we see in this graph is not going to be a parabola because we have three places where the graph crosses over the x-axis. So if we drew this graph, we would see it crossing over at 0, -5, and +1. So we might have a graph that looks something like this. Something that might look like this. Okay? Okay, example 6, we have 3c squared plus 7 equals 22c. So I can see that I need to set this equal to 0, so this 22c needs to be moved over to the left side. So let's start by saying that 3c squared will move over the 22c, so that's going to be -22c plus 7 equals 0. So notice that when I brought the c over, I went ahead and did two things at once. I put the 22c so it would be in descending exponential order. All right, next step is going to be to factor. So this one we need to use the X box or grouping method. So let's try that. Let's draw an X. We need two factors that when multiplied are going to equal to +21 and that when added equals -22. So you should be able to figure that would be the magic pair would be negative 21 and negative 1, because negative 21 times negative 1 is positive 21. Negative 21 plus negative 1 would equal negative 22. So we can solve this with the grouping method if we want to try that. Let's do that. So let's go ahead and write down 3c squared, leave ourselves some room, and then add our plus 7. And then in the middle, we're going to put our magic pair. So I'm going to put those in red. We're going to have negative 21c plus, minus c. So let's go ahead and group that. I'm going to draw my little dividing line, making sure that this negative associated with the c is over here on the right side of the line. Okay, so let's go ahead and figure out how to factor each side. So let's factor the left side first. I see that my greatest common factor here would be 3c, because 3c goes into each one of these terms evenly. So 3c squared divided by 3c is just going to be c, and negative 21c divided by c is just going to be negative 7. So let's go ahead and put that down. So we're going to have a leftover of c minus 7. All right, let's go back and see the right side. Now remember that I have this negative here next to the c, so that means when I factor, I'm going to be pulling out a negative factor. So the only thing that I can see that we can factor here would be a negative 1, because nothing else is common to negative c plus 7. So when we factor out the negative 1, I'm left with c minus 7. So now I can see I have the same leftovers. I have a factor, so let's go ahead and pull that out, of 3c minus 1 times the leftover of c minus 7. Okay, so now I'm ready to solve for x, because I'm going to set up my factors equal to 0. So the product of my two factors has to equal 0. So that means I'm going to set 3c minus 1 is equal to 0, and c minus 7 is equal to 0. This gives me 3c equals 1, or c equals 1/3, and c equals positive 7. If we were to draw a graph, okay, we would see something that looks like this. We would have 1/3 here, we would have positive 7 somewhere out like this, and then we would see a graph that opens up to the top that looks like this. Okay. Let's look at our final example, which is number 7. We have 15m squared equals 3 minus 4m. So we can see right off the bat that we need to move the 3 and the negative 4m over to the left side. I want to go ahead and do that in one step so that I can have my exponents in descending order. So let's see what that would look like. We would have 15m squared plus 4m minus 3 equals 0. So the first thing I'm going to ask myself, is there a greatest common factor that I can pull out? No, there doesn't appear to be one. All right, let's go ahead and set up an x and see if we can solve for the magic pair. So I want two factors that when multiplied together are equal to negative 45, and that when added together are equal to 4. So I'm thinking of the two factors of 9 and negative 5. Because 9 times negative 5 is negative 45, and 9 plus negative 5 is positive 4. So if we want to solve that, we can do that with grouping. So let's try that. Let's do 15m squared, and then we're going to put our minus 3 out here. And again, this is all equal to 0. Now I'm going to put my magic pair in the middle. It doesn't matter what order I put them. So I'm going to say plus 9m minus 5m. I'm going to draw my little dividing line, making sure that that negative goes on the right side and gets factored out on the right side. All right, so let's go ahead and start factoring by grouping. So I'm going to draw a line around here, and I'm going to figure out what is my greatest common factor. Well, I know that as far as a constant, 3 would be my greatest common factor, and then each one of those terms has an m, so I'm looking at 3m. When I factor that out, I'm left with 5m plus 3. Now on this side, I'm going to do the same thing. I'm going to figure out what my common factor is going to be. It has to be a -1 because there are no common factors for -5m and -3. So that's going to leave me with 5m plus 3. So let's go ahead and put that together. We get 3m minus 1, which again is just taking my 3m here and my minus 1. And then I'm going to multiply that times my leftover, which is 5m plus 3. And again, all that's going to be set to 0 so that we can solve for x. Okay, so in this example, we're going to set 3m minus 1 equals 0, 5m plus 3 equals 0, 3m equals 1, m is equal to 1/3. On this side, we'll get 5m is equal to -3. M is equal to -3/5. So our two answers or two solutions would be, m equals -1/3 and m equals -3/5. M equals 1/3 and m equals -3/5. Thank you for watching.